You might come across this in your forthcoming exam. Here's exactly how to crack it. An organ pipe of length 40, this is under sound wave. This is a sample from sound wave. An organ pipe of length 40 centimeters, open at both ends, sounds its fundamental note. Neglecting end correction, calculate the frequency of the note. And so we'll start with data. And next, we need to write out our data. The length of the organ pipe is actually 40 centimeters. So L is 40 centimeters. And please note, we won't make use of centimeters, so we need to just convert it straight up to meters. And how do we do that? We'd say 40 divided by 100. And would end up with 0.4 meters. This is established. And also, they say neglecting end correction, calculate the frequency of the note. Frequency of the note is what we are supposed to calculate. And we're giving velocity, which is the speed of sound in air, to be 340 meters per second. Next, we need to write out our relationship. The relationship between velocity, frequency, and length for an open organ or open organ pipe or an open pipe is actually frequency equals V over 2L. Frequency equals V over 2L. I'd rather write that down. I'll write it here. Frequency equals V over 2L. And I'm just going to go a little bit up. And frequency equals V over 2L, which is the formula I would make use of. So I'm just going to box this formula. And so this is what we'll make use of. And lastly, we'll plug in our data. Frequency equals V is 340, which is our velocity, over 2 times our length is 0.4 meters. Do not forget, this is the length that we'll make use of. This is the length we'll make use of, 0.4 meters. So I'm just going to punch my own calculator here. 340 2 times 0.4, you'd get 0.2 times 0.4 would get 0.8. So it's 340 over 0.8. And lastly, you'd say 340 divided by 0.8, and you end up at 425 hertz, which is the unit of frequency. And this should be your final answer. Would you like to solve similar questions as this? Click on the link in the description box. You win. Just believe.